Okay, question 2M3. Suppose that there are two globes, this time one for Earth and one for Mars. The Earth globe is 70% covered in water, and the Mars globe is 100% covered in land. In other words, no water. Okay. The question then asks us to assume that we don't know which globe that we've tossed, but we know that when we toss the globe, it produces an observation of land. And so then we're asked to find the probability that the globe that we tossed was actually an Earth globe. Okay. So notice that this differs from the previous two questions, 2M1 and 2M2. In those two questions, we knew that we were tossing a globe of the Earth, and we were trying to estimate, because we did not know, how much of the Earth was covered in water or land. Here, we know how much of each globe is covered in water and land, but we don't know which globe we're tossing. Okay, and so that's how this problem differs from the other two. So the first thing that we'll do is we'll assign priors. Now the question asks us to assume that each globe was equally likely to have been tossed, and so that means that that we are 50% for both Earth and Mars, and so I've done that here. Okay. Now, just one thing to look ahead into this book. Even if the question did not ask us to assume 50% for both, we may have landed on that as being our prior probability, and we may have reasoned something like, well, there's two options, and so the only way to divide 100% into two equally sized prior probabilities is to assign them both 50%, and that's completely fine reasoning. But this book will go into more depth about some of that reasoning later, and it will convince us that really the reason that we want to assign 50-50 in this case is that it represents maximal uncertainty. 50-50 represents us being maximally uncertain about which globe that we have, and without any other information other than we have one of two globes and they're both equally likely, 50-50 makes us most uncertain, and that is the place that we should be reasoning about these probability problems from. Okay. Also notice that in the previous problems we started by assigning a grid, where, let's see here, well, I guess we can just use this. All right, we started by assigning W grid and then began by plotting the prior over all of the different values. But now we're not going to do this because we're not considering, for example, we're not considering a prior probability for all values of W grid, right? We have one value representing our prior probability, which is 50%. So we don't need to concern ourselves with the rest of the possible prior values. Now, that doesn't mean that we couldn't do this. If we were to produce, call it a globe grid or G grid, we would come up with a graph something like this. But notice that all of the prior probability stacks up at 100%. Okay, and so because we're only considering very few values here, we're just not going to use the same methods that we were previously. Okay, so now we have our prior, and now we need to get our likelihoods. Okay, and so our likelihood is the probability of land given Earth. Okay, so again, a likelihood is saying what is the probability of the evidence here, the observation of land, given a hypothesis, and the hypothesis is Earth, or the opposite, probability of land given Mars. Okay, just a quick aside, notice that this differs from Bayes' theorem, the posterior, I'm sorry, not really Bayes' theorem, but the posterior probability. So this is the probability of the evidence given a hypothesis, but Bayes' theorem flips this around, and instead what it gives us is the probability of a particular hypothesis given the evidence. Okay, and so that's the difference between a likelihood and a posterior. But for the Earth, again, we want to know what is the probability of land, and so 70% of the Earth is covered in water, or of the globe, Earth globe, and so that means that there's 30%, 100 minus 70%, 30% of the Earth is covered in land, but 100% of Mars is covered in land. Okay, so we run those. And now before we plug everything into Bayes' theorem, which is right here, okay, you'll notice that we need this normalizing constant, okay? Probability of land, the probability of land, whether Earth or Mars, okay, for all possibilities, okay? So this is the formula for, in this case, for the prior probability, or I'm sorry, for the marginal probability. And so I have my marginal, and so I'm just going to insert it into our code here, run that. Okay, now finally we can come up with the posterior probability for Earth as well as for Mars. And so those are calculated here. And when I run those, we get that the probability of Earth given the observation of land is about 23%, and for Mars given land is about 77%. So these are our posterior probabilities for the two hypotheses. Importantly, because we only have two possible outcomes, either Earth or Mars here, these posteriors need to sum up to 100%, okay? And so if I add these together, in fact, that's what we get, 1 or 100%.